Hello and welcome back. FlexVPN Anyconnect with local authentication part 2. In this video, we are going to set up a very simple home lab using GNS3 to configure FlexVPN Anyconnect with local authentication on Cisco IOS XE router, but this time using client profile download feature. In my previous video, we configured FlexVPN server on iOS V router, but as we were using iOS XE version older than 16.10 that doesn't support client profile download feature, we had to create and copy client profile manually on the client side, and we also enabled the bypass downloader feature on local policy XML file. This requires some changes on the client side and might be undesirable. Here what I'm going to do is to leverage the Anyconnect profile download feature, so we will not have to do any changes on the client side anymore. In order to do this, we need iOS XE version 16.10 and higher. The idea here again is to set up a home lab with minimum resources and keep it simple. Let me explain our topology before getting into the configuration. You see here in diagram, this time we have a Cisco CSR1000v virtual appliance as VPN server. The Cisco Cloud Services Router 1000v is one of the NFV or Network Function Virtualization products by Cisco that is supported on many hypervisors such as VMware ESXi, Microsoft Hyper-V, and also you can host it on many cloud platforms like Microsoft Azure, Google Cloud Platform, or AWS. You can find detailed platform support information on Cisco's website. Here I'm running this router on VMware Workstation within GNS3. On the client side, we have Anyconnect client software version 4.8, TFTP server, and SMTP server for time synchronization. The router is connected to the MS loopback adapter on the client via this cloud. I already prepared basic management and IP addressing configuration on Notepad, so I'm just gonna copy and paste it. Let's do that. Again, the IP address that I'm using here is a private IP address, but this would be an IP address from your public IP address range that's going to be reachable over internet. You may also use private IP address if the VPN server is behind NAT. But anyway, your clients must have IP connectivity to the IP address of the VPN server. Before moving forward, let's check the connectivity between the client and VPN server by pinging this IP address from PC. Okay, we have basic IP connectivity between these two. Now let me explain the configuration steps I'm going to follow. First, certificate-related configuration that includes generating RSA key pair, CA server, and trust point configurations. Step 2, we are going to enable and configure AAA authentication and authorization methods. Then downloading Anyconnect client software and profile into the router, Anyconnect client installation package, defining client profile name and location. Step 4, client configuration parameters to be defined like IP address pool, split tunnel ACL, and DNS information. Step 5, IKv2 configuration that includes IKv2 authorization policy and profile. Step 6, IPsec configuration. Step 7, configuring virtual template interface, and finally step 8, enabling client profile download feature by configuring SSL authorization policy, SSL policy, and SSL profile. Now let's dive into the configuration steps and use the parameters shown in the picture. I'm going to create the RSA key pairs, so crypto key generate RSA with the label of VPN key and key length of 1024 as shown in the picture. Okay, key is generated. Now let's configure the CA server to obtain system certificate from. You may also obtain system certificate from your enterprise or public CA server. So let's say crypto PKR server with the label of CA. issuer name cn equals ca.homelab.net, grant auto, and activate it. No shutdown. Password to protect the private key. Then we should create a trust point so that we can send certificate sign-in request to and enroll for a system certificate. Let's exit from here. Crypto PKI trust point with the name of IOSCA, enrollment URL port 80. We don't need to do revocation check here, so let's say revocation check none with the subject name homelab.net CN. Now, before enrolling for system certificate, we need to authenticate and install the certificate of the CH servers first. So let's say crypto PKI authenticate IOSCA. Yes, we accept. We've got the certificate of the CH server. Let's verify this to show crypto PKI cert. The certificate of the CH server is installed. Now it's time to enroll for system certificate. Let's say crypto PKI enroll IOSCA. We don't need serial number in the subject. We don't need IP address too, so request certificate. The CSR sent and certificate received from the CH server. Let's verify this again. PKI cert. You see the certificate, system certificate actually is generated and issued by the CH server. The certificate part of the configuration is done. Now let's go to step 4. That's going to be the AAA configuration. AAA new model to activate AAA. We are going to use local authentication and authorization. So AAA authentication login with the label of auth C local. AAA network authorization for network access with the name of auth Z. This one also local. I'm adding a local user account to be used as remote client's credentials. So let's say username test with a password of Cisco. Step 5, before installing client package, we need to copy the installation file to the flash. So let's copy TFTP to flash. The IP address of the remote host is my PC's IP address, and the file name, let's copy this from here. I'm going to pause the video while the file is being copied. Okay, the package is copied to the flash memory. Let's verify that by dir flash. Okay, the Anyconnect package is already there. I also copied the ACVPN XML file using TFTP to the flash. I created this XML profile using Anyconnect profile editor. And now we can install the package and also configure the profile name and location. So let's go and say crypto VPN Anyconnect and the path of the file name, the package actually. The package installed successfully. Now let's define the Anyconnect profile, ACVPN, and the location of the file, acvpn.xml. Before getting into the IPv2 and SSL configurations, we need to define client configuration parameters to be pushed to the clients by authorization policies. So let's say IP local pool with the name of VPN pool 172.16.5.10 to 172.16.5.10. 5.20. By default, all traffic from the client PC will be protected and sent through the tunnel. The split tunnel ACL is used to allow only selected traffic to go inside the tunnel. So let's create one IP access list standard with the name of VPN ACL and permit 10.0.0.0/8. The IP address that we defined for loopback interface, and we want to test our connection by pinging that IP address. And then let's bring these two together under IKv2 authorization policy. Let's say crypto IKv2 authorization policy IK pol, that's label, pool VPN pool, and the split tunnel access list VPN ACL. For the IKv2 proposal and policies, I want to use the smart defaults actually, so I'm not going to create IKv2 proposal and IKv2 policies. Now let's create the IKv2 profile and bring all the pieces of IKv2 together under this profile by saying crypto IKv2 profile, IK profile. First, we have to match the identity of the remote side, match identity remote with the key ID of Anyconnect client. Anyconnect uses this value as its default identity, although you can change it using profile editor, but we will use this default one here. Okay. Authentication, local RSA SIG. So the client will authenticate the VPN server by its system certificate, and then let's configure an Anyconnect type of authentication for the remote end. Let's say authentication remote Anyconnect IP aggregate. Define the PKI trust point we defined. So PKI trust point IOSCA, actually the trust point that we got certificate from. And then let's apply the AAA authentication list we created before to this profile. AAA authentication Anyconnect IP auth C. And now let's bind AAA authorization and IKv2 authorization policies to this profile. AAA authorization group Anyconnect IP and IK auth C pol. And then apply this profile to tunnels by specifying the virtual template number. Virtual template, I'm going to use number 1. And finally, we have to enter the Anyconnect profile we defined above. Anyconnect profile ACVPN. Okay, configuration of IKv2 done. Now let's create the IPsec profile using default IPsec transform set and bind the IKv2 profile to it. Crypto IPsec profile, IPsec profile, set IKv2 profile of IK profile. We don't need certificate lookup based on HTTP URL, so let's disable this feature which is enabled by default. So no crypto IKv2 HTTP cert lookup. As we are going to use default port numbers for the SSL connections, let's disable HTTP and HTTP services to prevent any conflict. No IP HTTP server and no IP HTTP secure server. Then let's create the virtual template and apply the IPsec profile to interface virtual template with the type of tunnel, template 1 with the type of tunnel, IP unnumbered loopback 0 that we defined, IPMTU 1400, tunnel source would be gig 1, and of course tunnel mode IPsec IPv4. And finally tunnel protection, apply the IPsec profile here, IPsec profile with this label. Okay, When a remote client connects to the VPN server, a virtual access interface or tunnel will be created. The configuration of that virtual access interface is inherited from this virtual template. So virtual template interface is not an interface actually, it's just a container or template of interface configurations for virtual access interfaces. So what we've done is we've configured FlexVPN remote access using local authentication, but one last step remained, and that is client profile download feature. Now let's go to step 8, SSL configuration to enable client profile download. This is very similar to IKE v2 configuration. Let's create SSL authorization policy first. Here we are going to use the same pool and ACL we created and used under IKE v2 authorization policy. Crypto SSL authorization policy, SSL auth pool, pool VPN pool, route set access list VPN ACL, and also the client profile we defined above, ACVPN, to be copied on the client side over SSL actually. Then as iOS XE doesn't support SSL for data plane, let's set timeout to disconnect user session by saying timeout session 2. Then let's configure SSL policy by saying crypto SSL policy to specify the PKI trust point name and the local IP address to terminate SSL connections to. Crypto SSL policy with the name of SSL policy. PKI trust point IOSCA. IP address IOSCA, sign. IP address local 10.10.10.1 with the port of 443. No shutdown. And next we are going to create an SSL profile like what we did for IKE v2. Here we are going to match SSL policy, specify authentication and authorization parameters. Crypto SSL profile, match identity, match policy SSL policy we created above. AAA authentication user pass list of auth-C, AAA authentication method we created. Authentication of the remote end based on user pass. And finally, authorization group user pass list of auth-Z and SSL auth-Z policy. Apply the SSL authorization policy we defined above. Let's say no shutdown 2. That's it. VPN server configuration finished. Now it's time to test our configuration. This time we don't need to edit or add any profiles on the client side. Let's check out the client side before starting our test. The Anyconnect local policy XML, let's open this file. The bypass downloader is not enabled, which is a default setting. As you see here, we don't have any XML profiles. Okay, there's no profile. Now let's go and test our configuration. Connecting over SSL to 10.10.10.1, which is the default protocol Anyconnect uses. I'm getting this certificate warning because the certificate of the CA server is not trusted by the client, but we will accept it and say connect anyway. Okay, the ACVPN XML file created. As you see, we can check the inside. The label of the VPN connection is r1.homelab.net and the primary protocol is now IPsec. Now we should disconnect our connection and connect again, re-authenticate but this time using IPsec. This label is created here, re-authenticating using the same username and password. Let's verify the configuration or the outputs. Show crypto PKI, show crypto IQ2SA. The SA is created. Show IP interface brief. We see that virtual access interface is now up, is dynamically created for that specific connection. And show IP route. You see that there's static route pointing to virtual access interface with the IP address of 172.16.5.16. This IP address is assigned to the remote client from the VPN pool we created. Also, let's check the client side. You can see the route details. The access list, split tunnel access list, is applied here too. I hope you enjoyed this video, and if you have any further questions about this video, please ask in the comments below. And see you next time. Goodbye.